Kitchen Table Electronics, Advanced Topic 1 for Lesson 5, the root mean square value of a sine wave. So here is a sine wave expressed in terms of its period t. So this would be the argument omega t we've looked at before, where this is 2 pi f, which is the same as 2 pi over t, the period. So omega t now looks like 2 pi t little t over big T. Here's the sine wave drawn out. You can see it goes to a peak value plus V0 and a negative peak minus V0, so the total swing in voltage is 2V. However, the average of this sine wave over a period is 0 because it spends as much time at positive voltages as negative voltages. So the average of the quantity is not very useful. However, the average of the square of the voltage is very useful. Why is that? Well, that's because the power dissipated in a resistive component is V squared over R, so the average power over a cycle for an alternating waveform is V squared of T averaged over a cycle divided by R. So we're interested in the average of the square of the voltage, or to return to voltage-related quantities more simply, the square root of the average of the square of the voltage, i.e. the root mean square value of V. Let's go ahead now and evaluate this. So we want this quantity, which is this quantity here. Okay, how do we do this? We must integrate this quantity over a period and divide by the time of a period. And I should probably put a V0 squared here. Okay, now this is a rather awkward integral because we have a sine squared, but recall from the addition formulae that sine squared of theta is 1/2 of 1 minus cosine of 2 theta. So let's substitute this into here, and we now have a new integral then. And now it's 4 pi. And let's evaluate this. And the first term becomes simply t. Here we have to take the derivative of this term here with respect to t and invert it because we're integrating with respect to t and not the argument of the cosine. And so that becomes then, and cosine goes to sine. And this is going between 0 and t. So the first term pulls out simply a t, which cancels this t down here. And the second term is clearly 0 at 0, and then at t it's the sine of 4 pi, which is also 0. Therefore, the root mean square value is the square root of this quantity, or V0 over the square root of 2, or about 0.7 times V0, or V0 over about 1.4.